friends, students, enthusiasts. Welcome back to my channel. So one more project, a very simple project, especially for the beginners who want to use Raspberry Pi Pico board and do some project with MicroPython. So this project is Raspberry Pi Pico Zero board, that is small board of Raspberry Pi we have used. We will make a digital oscilloscope with this. So the language we have used is MicroPython. Okay, so it's very simple digital oscilloscope by using a small display. This is for the beginners who want to have idea with Raspberry Pi Pico board and MicroPython. Okay, so we will just see what are the components we have used. So we have used Raspberry Pi Pico Zero board. You can see here the small form factor, very small board. Then SSD1306, a very 1.3 inches OLED screen. Then breadboard, we have used a smaller breadboard. We can make it, we can fix this as well as this on that. And we have used 4 switches. Okay, these are 4 switches with some jumper wires and some resistors of 100K and 10K. Okay, and source either you can use a battery. Why? Because this will work with a single battery of 3.7 volts also. So these are the things what we have used in this components we have used in this. So simple block diagram I will explain you. The input signal, that is the 2 probes, one is ground and one is signal probe. That is connected to pin number 26. Okay, so we will make a voltage divider by adding 100K, that is 100 kilo ohm resistor through. That means signal will go through 100 kilo ohm resistor, and the other end is connected through a 10 kilo ohm. The in between 100 kilo ohms and 10 kilo ohm, we will connect it to GPIO 26 of the Pico board. Then it goes to Raspberry Pi Pico. Naturally, high-speed sampling will be generated, waveform buffer will be created, OLED graph will show, and SSD1306 will make a display where you can see. Okay, so the small circuit diagram I have just made it on the left-hand side. You can see how the things are connected, and the pin connections I have given on the right-hand side. Analog input protection, signal input, that is for protection on that I told you 100 kilo ohm resistor we have used, which is connected to GPIO 26 through this signal, which will be signal will be going through 100 kilo ohms. Then another end is 10 kilo ohms to ground, and the middle point goes to GPIO 26. That is analog connection of the board. OLED connection simple, GPIO 4 and GPIO 5, that is SCN and SDA. That pin, this also works on 3.3 volts and ground. 4 push buttons we have used. Okay, it is connected to GPIO 10, 11, 12, and 13. By this button, when you press this button, the microsecond division which will be displayed on your screen will go according to that speed. Okay, so 1 microsecond per division. GPIO 11 switch, if you press, that is 5 microsecond per division. Here you find the switches and so on. The last is 50. 50 will be a little slower. It will be this thing. Okay, so let's see it. We'll go to our lab and see how it is working. Please remember these 2 points. This is signal point and this is ground. Okay, it is connected to ground. So one is connected through 100K, another is directly to ground for protection, as I have given it here. So let's go to the lab and check it out. In our lab, as you can see, this setup over here, a small board has been used. Okay, smallest this board has been used. So I have fixed my Zero board, that is RP20400 board. I can take RP20 Pico board also, that is 2350 also. I can use the same boards will work for that. This is my display, that is 1306 with 4 connection, SLSD, where it is given. You can check it out, 4 and 5 connection. So this side is a power. I have connected 2 buttons. In fact, there are 4 buttons. Okay, one for 1 microsecond division and for another 10 division. Right now you can see 10 microsecond division is going on. So let's change it to some other microsecond division. I can just press, I will just try to press it. Okay, now it is 50 microsecond division. Okay, so now you can see this is my main probe. This one, this black color is the main probe. This is my main probe. Okay, so if I connect this probe to pin number, say 15. Okay, let's see what happens. Okay, you can see the graph has changed. We can adjust it because I have used only 2 buttons over here. Okay, so 50 microsecond, you are getting this. This is the thing. And now we'll change it to, let's change it to 10 microsecond. As you can see, it has changed, and the function of this thing has also changed. Okay, now you can see this. I'm touching my hand. You can see here, I'm just touching my hand to the probe and how this thing will be going on. Same time, it's a voltage division and the microsecond division, everything will be seen. So we can go for a 4 setting. Okay, so please remember this probe. just for sake of just protecting it, through 100 kilo ohm resistor I have connected, and one 10 kilo ohm resistor is going to the ground. Okay, so this switch is the only connection, as I've already discussed. So you can do it very small. We can see the different waveform. If you make it to a flow slow and fast, everything can be done over here. This is 10 this thing. If you want to make it 50, it goes to 50 also. You can see here. Okay, as we have changed it to this thing. And 10, then you can reduce it to 1, you can reduce it to 5. So all the switches will be. But I have just connected two switches, very simple. Switches, one end will go to ground, another end will go to the GPI pins. I've given you the schematic diagram. The students who wants to do a project related to this, that is DSO, they will get a knowledge from this. I have codes in MicroPython, as you can see. This is Thorny ID. In Thorny ID, these are the codes which I will be sharing with you. You have to put mains py. Okay, then only you can connect external battery. Since I have given only connection now through the laptop supply, okay, through my computer. So now I'm getting power, but if you want to give separate power, that is to pin number 5. That is this point. Okay, the first point you have to give this one, the first point, and the second point is ground. So if you want to give to battery, then you have to connect, or you have to store it with main py inside your Pico board. Okay, so we have used these are the first libraries what we have used. Then the description about the pins, that is OLED pins and connections. Frequency 40,000 for we have given. Oh, sorry, 400,000 we have given. ADC 26, that is ADC 26 we have connected. Buffer is 28. So pins where it is connected, the button 1 is at pin number 10 and all. This is about the pin description. And 1 millisecond division, if it is equal to 100 time base, this is the information about how the things will be changing. Okay, so here value 0, then 500, then 500 division, then it is coming to 500 and then to 1000. That is nothing but 10 microsecond per division. Okay, so this is to be written in the code. And rest of the code, how the graphics will be there on the screen. Other things you can just go through it and while too, and it will be there. So I hope you will like this project. If you have any idea, or any further ideas, you can implement it. And very simple. The only thing what we have tried is with the Pico board using a small display. How can we make a digital oscilloscope? Okay, which can really work. We can call it as a pocket oscilloscope using MicroPython. I hope you like this project. And if you like it, please share with your friends. If any questions are there, please do ask me, write in the comments. Thanks for watching. See you next time. Bye.